interested primarily in oxygen and the brain. We've evolved with the brain being really oxygen hungry. We know that in certain disease states, if there's not enough oxygen delivered to the brain, it can cause problems.
Concussion is a big issue in the game of rugby. We hope this research will be of use to the game and perhaps lead to some changes in the laws.
We're very interested in the mechanisms that allow oxygen to get to the brain. And exercise is a great example of stressing the brain. The brain needs more oxygen and it needs to increase flow to get the oxygen and the nutrients to it. We're amongst the first to characterize what happens to the brain during acute exercise. And we focus on the mechanisms that regulate oxygen delivery to the brain and what are the longer term benefits associated with adaptation to exercise. Here we look at acute hypoxia, acute high altitude based work, because it challenges the brain with less oxygen and the brain is going to work jolly hard to try to recover from that. I originally started off my specific area of research some 20 years ago now, interested in oxygen, arguably the most important molecule in the world. We've evolved with oxygen. And what I was interested in are the mechanisms that regulate oxygen delivery to the brain. There's a lot of talk about free radicals. They're very difficult to measure because they're so transient. They're invisible molecules, if you like, that float around in the bloodstream that at the time were considered just bad and nasty, and we needed to mop them up and get rid of them with antioxidants. My research used novel techniques to be able to measure the free radicals for the first time in the exercise in human circulation, to detect certain types or species of free radical, and then we could target those, knock them down, and look at its impact, if you like, on the physiology. We're keen to provide some very clear, objective, integrative evidence to look at the molecular, hemodynamic blood flow and structural changes that occur as a result of repetitive concussion. What we're keen to do is to audit the brain to see what's happening, and then we're in a position, once we've unraveled the mechanisms, to deploy more effective countermeasures. So my ultimate goals really are trying to understand where in the brain does the sensing of oxygen take place. How do I taste oxygen? And then what are the mechanisms at the molecular level that then send alarm systems to say, hey, this isn't enough, it's not quite right, the concentration or the level. This is what I need to do now to try to salvage oxygen delivery to the brain. Does the oxygen sensing, the cerebral oxygen sensing, the brain's ability to taste, smell oxygen, does that determine our trajectory towards disease? And that will also help unravel some quite novel targeted interventions in order to slow down disease.